Hey everybody, we are starting chapter 5. Woohoo! We're talking about modeling inverse and joint variation equations. So here we go. Let's jump right in. Here's some key vocabulary. Inverse variation. So this is when two variables, x and y, show inverse variation if they are related as follows. So y equals some number a divided by the variable x. And then also a is not 0. So a is a number, a is just a number, but x and y are variables. So when y equals something divided by x, that's because y gets bigger when x gets smaller, and vice versa. When x is bigger, y gets smaller. That's called inverse variation. The constant of variation is that value of a, and a is just a number, aka a constant, as x and y vary inversely, which means they don't grow together. As one grows, the other one diminishes, and vice versa. So remember way back when we learned these other kinds of joint variation functions, some number equals x, and this could be, like as you buy, I don't know, let's say you go to the dollar store and you buy 20 pencils. We know that the cost that you spent was $1 per pencil. So the cost goes up as you buy more, right? So this that we learned before is called joint variation. And joint variation means, or I shouldn't say, sorry, pardon me, not joint, direct variation. That's what I meant to write. Direct variation. And that's because as you buy more, the cost of it increases as you buy more. Other things that could go with this, your grade, your GPA can go up as you study more or spend more time on work, things like that. So let's talk about this, classifying direct and inverse variation. So keep in mind that the trick is that the direct variation looks like this, something like y equals some number a times x, whereas inverse variation will look like y equals the number a, but instead of being multiplied by x, we're dividing by x, okay? So remember that the trick is get the y by itself, because both of these, the y's are by themselves, and that's how we can really see what's going on. So let's do that. So here we go. We need to see if this is direct, inverse, or neither of those. So we're going to get y by itself. So in order to get y by itself, I'm going to divide both sides by x. So I'm going to go, if I've got xy equals 7, I'm going to divide both sides by x. And I get y equals 7 over x. Well, doesn't this look a lot like inverse variation? So this is inverse variation. Okay, let's look at this one. Again, the trick is to get y by itself. This y is already by itself, and we see this is, oh, it's x plus 3. Well, we're not dividing and we're not multiplying like in direct and inverse, so this is what we're going to call neither direct or indirect variation. And then lastly, for part C, we've got y over 4 equals x. So again, we're going to get y by itself. So in order to get y by itself, I'm going to multiply both sides by 4. And that will cancel out here on the bottom, and we're left with y equals 4x. But doesn't this look just like this? I'm going to put it in green, this direct variation right here. So we call this direct variation. Okay. All right, so this example number 2 is kind of specific, and we want to break it down into 2 different parts. So the first thing they are asking us is write an inverse variation equation if, and this is the first part, variables x and y vary inversely and y equals 7 when x equals 4. So that's the first part. And then, secondly, they want you to write an equation that relates x and y and then find y when x is negative 2. So first things first, you break this up into 2 points. We know that we're going to be using an inverse variation equation. So we know inverse variation is y equals a over x. Here's the thing. Remember how a is a number? We're going to find a. So the first step is we're going to find a, and we're going to we're going to do this using these green pieces of information that we just have right here. So then we're going to go plug this in, y, which is 7, equals a, which we don't know, over 4. Okay, so now that we've got that set up, let's solve for a. So in order to solve for a, I'm going to move the 4 away from it. Since it's being divided by 4, I'm going to multiply both sides by 4. And I get a equals 28. So that's what the first step does. It helps us find that value of a. So now we're going to do the second step, which is this blue information. And so now we're going to find the equation that relates x and y. Remember, again, inverse. So we say y equals a over x. Then when y, we're going to find y when x equals negative 2. So we're looking for y. We know a, we already found it, was 28. And x is negative 2. So y equals 28 over negative 2. And we divide that. We get negative 14. That's our answer. Good job. Now, let's check for data. Sorry, this is so close. But let's check for data. If I'm looking for an inverse variation pattern, let's look at our data. So 58, 62, 66, 70. Do you see how they increase as they go up? But if we're looking at this, 40, 448, 424, 392, 376, these are decreasing as we go to the right. So if you see the numbers as we go to the right, the area is going up where the number is going down. That tells us it's an inverse variation function. All right, last thing, let's talk about joint variation. So it's just like direct variation, but we've got more than one or two or more quantities or variables. Okay, so keep in mind, these a values are still a number, but the other variables are we don't know what they are. So there's at least 2, sometimes 3. And the way that we would say this one is z equals a some number times x and y, or z varies jointly with x and y. And this is p varies jointly because they're being multiplied as q, r, and s. Okay, so let's write a joint variation equation. So remember, joint variation is like direct variation, but we're multiplying a bunch of variables at the same time. So the variable of z varies jointly with x and y. So we would say that z varies jointly with x and y. Z equals negative 75, so we put that here. That might be a point. Let me see if I wrote that wrong. Yeah, no, it's just negative 75 equals, we don't know what a is, and then they're saying x is 3 and y is negative 5. So if I want to solve for a, we're going to solve this. So negative 75 equals a times 3 times negative 5 is negative 15a. Divide both sides by negative 15, and we get a is 5, or negative 5, right? So that's the first part. Then here comes our second part, find z when x is 2 and y is 6. So we're going to go back to our original equation right here. So we're looking for z when x is 2. So remember, we just found a is negative 5. And then we know a is 2 and x is 2 and y is 6. So let's solve for z. Negative 5 times 2 is negative 10, times 6 is negative 60. And there is our answer. Okay, last thing we're going to do, we've got Inverse, remember inverse is division, jointly is multiplication. So if inverse varies inversely with x, we say y equals, is the inverse varies, a over x, because inversely means division. Z varies jointly, so we're going to say z varies jointly means we're going to multiply some number a times x times y times r. Lastly, if y varies inversely with the square of x. So keep in mind, square root of x is x squared. So y varies, we're going to write y equals inversely, that means division. So we're going to say a divided by square of x, which is x squared. Let's look at the next one. Z varies directly, so we say z varies directly, so we're going to multiply a times y. Oh, and this is a double one. Inversely means divide now, so we're going to divide it by x. Last one, and then we're done. X varies jointly, so we're going to multiply. So x equals a times t and r, and inversely division with s. And that's it. All right, I'll see you back in class.